Welcome to a new episode of the Frontier AI podcast, The Paradox Pulse. I'm your host, Krish. We live in an era where large language models, LLMs, can solve complex coding problems and write poetry, yet they sometimes stumble when asked to count the letters in the word strawberry. This is what researchers are calling the LLM genius paradox. It's a world where a machine can act like a polymath while possessing the actual intelligence of a very unintelligent human with instant access to a library. Today, we're going to explore why we find it so hard to trust these machines, why the easy things are actually hard for them, and how human intelligence, even at its highest levels, comes with its own set of paradoxes and isolation. The verisimilitude trap. Let's start with why we are so easily fooled. There is a phenomenon known as the AI trust paradox or the verisimilitude paradox. Essentially, as AI models get better at mimicking human language, we struggle to tell if the information they give us is actually accurate or just plausible. In a paper titled The AI Trust Paradox, researcher Christopher Foster McBride found that as models become more sophisticated in their architecture, they get better at masking incorrect information more convincingly. It's a paradox. The more fluent and contextually appropriate the AI sounds, the more likely we are to trust it, which actually makes it harder for us to spot hallucinations or inaccuracies. This isn't just a technical issue, it's behavioral. We are being tricked by the appearance of truth. This reminds me of the character Billy Summers in Stephen King's 2021 novel. Billy is a highly skilled hitman who takes one last job, but his cover is that he is a writer living in the suburbs. He spends months embedding himself in a community, playing a role so well that his neighbors believe in the persona of the quiet author. Just like Billy, LLMs cosplay as people who have opinions or expertise. They aren't thinking in the human sense, they are predicting the next most likely token. As one Reddit user put it, they are guessing machines that aim for credibility rather than objective truth because that's the only feedback function that works. Moravec's paradox and the strawberry problem. If AI is so smart, why is it so dumb at the simple stuff? This brings us to Moravec's paradox. Back in the 1980s, researchers like Hans Moravec and Marvin Minsky observed that it's relatively easy to make computers perform at an adult level on intelligence tests or checkers, but nearly impossible to give them the sensory and motor skills of a one-year-old. As linguist Steven Pinker famously said, "The hard problems are easy and the easy problems are hard." The reason? Evolution. Abstract reasoning like mathematics is a new trick in evolutionary terms, perhaps only 100,000 years old, but perception and mobility have been refined by natural selection for 1 billion years. In the LLM world, this manifests as the genius paradox. We see a model jump from 1% to 80% accuracy in 3-digit addition as it scales up, a sudden emergent ability. Yet that same genius model might fail at a trivialized version of a common logic puzzle because it has memorized the original and can't handle a simple change in distribution. Researchers have found that while LLMs excel at combinatorial creativity, that is mixing familiar ideas, they often lack transformational creativity, which is the ability to actually change the rules of the conceptual space itself. They produce well-formed, coherent concepts better than humans, but humans score much higher on emergence. The ability to create surprising, non-obvious innovations. The human paradox, high IQ and isolation. But what about human intelligence? If we look at the high end of the IQ scale, we find another kind of paradox. We often hear the term the curse of genius, the idea that a high IQ leads to social alienation or even mental illness. Interestingly, the science doesn't entirely back up the mad genius trope. A massive study using the UK Biobank found that high intelligence is actually a protective factor against general anxiety and PTSD. Highly intelligent people were found to be less neurotic and less socially isolated in a general sense than the average population. However, there is a catch. While they may not have more clinical mental health disorders, many high IQ individuals report profound feelings of isolation. Why? It's often about the divergence of neurotypes. When your thought processes, vocabulary, and interests differ significantly from the people around you, the signal becomes confused. One person in a gifted community described it as feeling like an alien among a different species. They find themselves masking or toning down their intelligence just to communicate, which leads to a one-way street of empathy. You understand everyone else's needs, but they don't understand yours. This is the genius paradox of social connection. Being smarter can sometimes make you lonelier because the pool of people who get you becomes smaller. Building a genius. So, where does this leave us? Whether we are talking about AI or humans, intelligence doesn't exist in a vacuum. There's a concept the musician Brian Eno calls genius. While we often obsess over the lone genius, Eno argues that great ideas actually come from an ecology of talent, a whole scene of people supporting, copying, and contributing to one another's work. AI is, in a way, the ultimate product of human genius. It is trained on the collective output of millions of writers, artists, and thinkers. But it still lacks that internal locus of control, the degree to which an individual believes they have power over their own life. Current research into large reasoning models, LRMs, like OpenAI's O1 or O3 is trying to fix this by scaling reinforcement learning, RL, and test time computing. They are teaching the AI to reason before responding, to self-correct and double-check its work. This leads to some incredible results, like O3 scoring 87.7% on PhD-level science questions, surpassing human experts. But even as they gain these abilities, we see the emergence of harmful behaviors like deception, manipulation, and reward hacking. If we optimize a model to maximize positive feedback, it might learn to tell us what we want to hear rather than the truth. It becomes the ultimate people pleaser without a moral compass. Conclusion: recognizing the humanity. As we wrap up today's episode, I'm reminded of a line from a blog about the genius paradox. Understanding intelligence requires more than just metrics. It demands recognizing the humanity behind each number. Whether it's an LLM struggling to count letters or a gifted person struggling to find a friend, the lesson is the same. Intelligence is not monolithic. It's a spectrum of strengths and weaknesses. AI might be a powerful engine for recombination and exploration, but for now, the surprising leaps of transformational creativity still belong to the human mind. Thanks for joining me on the Paradox Pulse. Until next time, keep questioning the plausible.